definitely a calculator problem here. I thought the last one wasn't too bad because it was a polynomial, and so we could do a lot of things without the calculator. Here, this is going to be like completely calculated, right? Because I'm not doing anything with this. That would be quotient rule, chain rule. Yeah, no thank you. A particle moves along the x-axis with the velocity given by maybe our little picture. We're thinking about position, velocity, acceleration. So this time they gave us velocity rather than speed, or rather than position. Find the acceleration of the particle at time equals 3. Okay, well, then I don't want you to tell me an answer right now, because that would be super impressive if you knew. What am I going to do to find the acceleration of that particle? V prime, it is S double prime, but they gave me V, so I don't need the double prime thing. I just need the derivative of that guy. And especially since this is a long equation, I'm going to put that in for y1. That way, anytime I need it, I can just use y1 and not have to type this thing in a bunch of times. It would be, wait, no, we're good. 10 sine 0.4 x squared over x squared minus x plus 3. What are you guys looking for? Fraction bar? Alpha F1. F1 will give you the fraction bar. Not needed, but I think easier than parentheses. So just be careful. I suppose I could graph it. Do you guys want to get the derivative off the graph or just from the equation? I heard both. Okay. Let's see. The time is from 0 to 3.5, so I'll go like -2 to 5 just to make sure I see everything. I didn't change my Y window at all because I had no idea what this was. So I could zoom in a little bit more on the Y stuff. Maybe just go -5 to 5. Again, you can use the graph or you can do it on the main screen. I think I like the graph better because it shows me a picture and I can have a better feel for what's going on. I don't know which one is fewer keystrokes. Pretty close to the same probably. So second calc gets me dy dx, and then I can just type in 3, and so there's my answer. And it puts a little x on the graph, so I can see that, yeah, sure enough, the velocity is decreasing there, so the acceleration is negative. And that's all the work you have to show, is just tell me that you took a derivative of v, -2.118. Then that's it. If you liked it the other way, it's math 8. Derivative of, I'll do this quickly, y1 when x is 3. That should give me the same number, -2.118. So how did I get the y1? Math 8. Oops. Respect to x. Y1 is a variable, so go to vars, and then yvars, and we are definitely not doing parametric and polar stuff. So function, and then there's y1. So again, either way, you can do it on the graph or you can do it on the main screen. Part B. At what time intervals between 0 and 3.5 does the particle move to the left? Justify your answer. Okay, so James, how do I know when a particle is moving to the left? So don't worry about this particular problem, just in general, how do I know if a particle is moving to the left?
If it's negative.
If what's negative? V. Yep, be careful with the it. So moving left when V is less than 0. Okay, that's always true. Now let's start thinking about this particular problem. This is a graph of V, how do I know, looking at that graph, when V is negative? What am I looking for? I don't think maximums and minimums. I want to know where the graph is less than 0. So picture-wise, it's like, oh, right down there, V is negative. So let's find those spots, and that'll be my answer. So how do I, remember how I find that spot? Let's see, second calc 0. Second calc 0. Left bound means get to the left. Right bound means get to the right, and then just hit it again for a guess. So 2.802. That's when the velocity goes negative, so that's when it starts moving to the left. I don't know if the picture would help us here or not. So like in here, we're moving left. Over here, we're moving right. Because if velocity is positive, we're moving to the right. If velocity is negative, we're moving to the left. So I need to go find that other 0. Left bound, right bound, guess. 3.963. Second calc 0. Okay, so there's something kind of weird about that answer. So I'm moving to the left. It starts at 2.802. And where does it, what's the end of my interval? 3.5. Good. So I looked at more than I needed to look at. I'm only supposed to go to 3.5, so let's stop it at 3.5. And I guess we could include 3.5. This is one where you can include or exclude the 2.802. Because you're...
Sorry, why would you do 3.5?
Because they put an end to this problem at 3.5. So my calculator kept going, but I'm supposed to stop it at 3.5. I mean, one way that I could have got around that is to not even look past 3.5. So if I'd have done this on the calculator, then maybe that would have been a better option, because it goes negative at 2.802 and then stays negative for the rest of the interval that I'm looking at. At what time between 0 and 3.5 is the particle farthest to the right? Farthest to the right. So, Holly, what am I thinking about here? What am I looking for? How do I know when the particle is farthest to the right? When what changes positive to negative? So yeah, something is changing positive to negative. But what is changing positive to negative? V. Because if V is positive, I'm moving to the right, and then when it changes negative, I'm going back. So my farthest spot would be where V changes positive to negative. Or at least my potential farthest right spot. The good news is we've only got one of those. So we're moving right this whole way, then we move left. It only changes direction one time. So I don't have to figure out, how far right on each of the changes were there. V changes positive to negative. Oh, we already have that time. Yeah, at 2.802. I guess we should also add there's only one change of direction. Right, if there was more than one, then I'd have to figure out, well, which one was the farthest of the farthest right. And really, we don't know how to do that yet, so that's why there's only one change of direction. On what interval is the particle speeding up? Aslan, what am I looking for speeding up? Okay. No, that's everyone's first answer, though. V and A have to be the same sign. V and A have to be the same sign. So speeding up, V and A, same sign. So, Ava, what do I need to do to help me, like what's the process to help me figure out where A and V have the same sign? Do you remember this from the, we're here, so like, we sort of have a velocity number line already, because we said at 2.802, the velocity was positive up to there, and negative after there, at least as far as out as we wanted to look. So Ava, what else do I need to look at to know when V and A have the same sign? We've got a velocity number line. That helps me with velocity. What else do I need to answer this question? So I need a V number line and I need an A number line. Okay, so I need to know where A changes signs. How do I look at this graph and figure out where A changes signs? I heard a great word there. A is the slope of V. So let's see. A changes signs right there. The slope of V changes signs. I'm saying right there. That maybe that's not super helpful. So right there, the slope changes. That's a maximum of V. Second calc 0. Whoops, not 0. Second calc maximum. And it's another left bound, right bound guess thing. So at t equals 1.713. To the left of that, the slope of V is positive. To the right of that, the slope is negative. Although it does look like it turns the corner again way over here. I think I'm looking at 3.5. So I need to figure out if there's a min down there where it changes way out there close to 3.5. Second calc minimum. I'm looking for where the slope of V changes. Left bound, right bound, yes. And I'm real close to the edge. It's kind of cruel that they put it that close to the edge. But that's within the interval I'm looking at. So I need to include that 3.362. Because at 3.362, the slope of velocity changes signs, which means the acceleration changes signs. Okay, so now I've got my overlapping number lines. I'm looking for the same sign. So that would be from 0 to 1.713. And then they match again, starting at 2.802 up until 3.362. When the signs match, you're speeding up. When the signs differ, they're fighting each other, you're slowing down. Part E, and final. A second particle moves along the x-axis with position given by. Okay, so it's a separate particle, but now I'm given position. So let's slow down before you even read that. So I've got two particles now. One of them I know the velocity for, the other one I know the position for. T squared minus t on the same time interval. At what time, so I'm looking for t, are the particles moving with the same velocity? So I need V1 to equal V2. Well, I've got V1. That was the, I'm going to relabel that thing. I've got V1. No problem there. What's V2 equal to? How do I figure out, Elsie, how do I figure out what V2 is?
You'll take the derivative of
Yeah, of that. And Jake, what is the derivative of that? The derivative of x2.
2t minus 1.
Good. Okay, I don't really want to write all this stuff out again. I've got V1, I've got V2. I want to know where they intersect. So how should I do that? Set them equal. I mean, that's true, but I don't want to do this like algebraically because I don't know that I could do this algebraically. So that probably gets you 1 point. Free response questions on the AP test are worth 9 points. I'm almost positive this is an old AP test question. That probably gets you 1 point making it this far, like realizing you took a derivative, you set the velocities equal. Now I need to figure out how to solve that to get that last point. And again, I don't want to do this algebraically because that's going to be yuck, probably impossible.
put them both in y equals.
There you go. Put them both in y equals. One of them's already in y equals. The other one is just 2x minus 1. And so, okay, but what am I looking for? Where they intersect. You remember seeing that word anywhere in the menus that we've looked at? Second calc. Everything's in second calc. Second calc. Intersect. And again, you make it that far, it walks you through what it wants. First curve, question mark? It defaults to the first curve, so you can say enter is yes. Second curve, you can't really see it maybe, but it flipped it to the second curve, so enter. And guess, if you've got multiple intersections, get it to the one you want. This one only has one, so we'll just get kind of close to that intersection. So that happens at t equals 1.571. What time are the two particles moving at the same velocity? And that's all the work you have to show. I know, the graders know, you've got a calculator, you can use it, and so that's where they intersect. Alright, we did two of the harder problems together. How you want to do the rest of these problems, when you want to do them is up to you. I will say that on Monday, I will work the odds off of the review in class. So the next worksheet page is worksheet 4, the review. Second period, I'll work the odds. Fourth period, I'll work the evens, and then I'll post the video. That way they'll all be there. But I'm telling you ahead of time, that way if you want to work on the odds so that we'll be working the same thing before Monday, if you want to work the evens and then I work the odds and then you're done. Some of you aren't going to do anything. You'll just work the odds with me on Monday and then work the evens later. It's up to you. Everything's due on test day, but it'll all be due on the second test day, yeah. So you can sort of plan out when you want to do what.